This conference will now be recorded.
All right, this is the brief calculus review for test 4. I had a couple emailed questions. I'm going to go through those right now. Starting with number 2, I had 3 different questions asked about number 2, which was for A, B, and C. We're finding the indefinite integral by using a substitution, which means we're just doing an antiderivative, but we have to make sure this works out using substitutions. So typically you pick the part that looks the most complex, which is the part under the radical. So we'll do 1 minus 3x squared is going to be our u. We take the derivative of that with respect to u, so that's going to be negative 6x dx. Now the problem is we have a 4x. Now if you want, you could pull that 4 out to the beginning before you do any adjustments. And then this would be just x over the square root of 1 minus 3x squared dx. If we get a negative 6 here, we'll be fine with that, but to counter that, since we multiplied, we need to divide by negative 6. So that actually makes the beginning a negative 2 over 3. And then we have our integral. We'll separate this out as 1 over the square root of u and then du, because the square root was not part of the u, it was just the inside. I would then move that up and use a negative exponent and a rational exponent to explain it, so negative 1/2. So now we're ready to do the integration of this. So that means we add a power. So if you add 1 to negative 1/2, it would be 2, just 1/2, positive 1/2. So negative 2 over 3. We would have u to the 1/2, and then we divide by that. And then remember, that would be a plus c. Now when you divide by a fraction, you actually multiply by its reciprocal. So this ends up being times a 2 on top over a 1. So this would be negative 4/3 for our fraction out front, and then we would use our 1 minus 3x squared to the 1/2 power plus c. You could turn that back into square root if you want, or you can leave it like this. I believe she left it like this on the answer key. So let's look at part B. It says 8x, we're doing the antiderivative of 8x, parentheses 1 minus 4x squared to the 5th. I would let my u be the part inside here, so that's going to be u is 1 minus 4x squared. So du is going to be negative 8x dx. And then we would have, sorry about that, we would have a negative that we needed to add in. If you add a negative on the outside or the inside, you have to do it on the outside as well. So this is negative, and this would be u to the 5th power du. And then we do the integration, so that's going to be u to the 6th over 6 plus c. All we have to do is plug back in the original part. So I know on the answer key she wrote it as negative 1/6 because this is like having a 1 on top. And then it's 1 minus 4x squared to the 6th plus c. So there's the answer for that one. Okay, and then C part on this one, we need to let the, if it's E is involved, you usually let its exponent be the U. So this is U equals x squared plus 1. So du is going to be 2x dx. We already have a 4, so we're going to cut it in half, which means we'll multiply by 2 over 1 to counter that on the outside. So this is now 2, and then it's e to the u du. And then that would be e to the u, which is its antiderivative with a 2 still in front, plus c. So 2e to the x squared plus 1 plus c. So there's how you work those 3 parts on number 2. I also received a request for A and B on part 3. So let's look at this. These are definite integrals, which means we still do the same process, but then we evaluate it using the fundamental theorem of calculus, which says once you've taken your antiderivative, you apply the 2, and then you minus what you get when you apply the negative 1 to that. So this is just a polynomial one, so this would be 4x squared over 2 plus 3x, which is going to be just 2x squared plus 3x, evaluated from negative 1 to 2. So remember, you plug in the 2 first. So this will be 2 times 2 squared plus 3 times 2, so that's the first part, minus 2 times negative 1 squared plus 3 times negative 1. And then we want to work this out. So this is going to be 2 squared is 4 times 2 is 8. 3 times 2 is 6, so this first parentheses is 14. This is negative 1 squared, which would be 1, times 2 is 2. That's minus 3. So this is minus a negative 1. So it actually ends up being plus. So it's going to be 14 plus 1, which is 15. And remember, we said that is units squared, even though she didn't put those on the answer key. Okay, for the next one, we're going to do the antiderivative again. E to the x's antiderivative is just e to the x, and then we have a minus 5x. We're going to evaluate this from 0 to 2. So if we plug in 2, we get e squared minus 5 times 2 minus e to the 0 minus 5 times 0. This is e squared minus 10 minus e to the 0 is 1. That's a 0. So this is going to be e squared minus 11. That's the exact answer. The approximation on that is negative 3.61 if you type that in on your calculator. All right, so for number 4, I was requested this one as well. It says find the particular solution that satisfies the differential equation and the initial condition. The keywords there are the particular solution. That means we're going to take the antiderivative of this, and we're going to have our plus c, and then we're going to plug in the 1 for the x and the 2 for the big f of x, and we're going to be able to solve for that c. So this is the antiderivative of 6x cubed dx. So that would be 6x to the 4th over 4. Plus c, that's going to equal our big f of x. We can reduce that, so big f of x is 3x to the 4th over 2 plus c. We're going to plug in 1 for all the x's, and this is our big f of x. So we're going to have 2 equals 3 times 1 to the 4th over 2 plus c. So that's 2 equals just 3 over 2 plus c. Subtract 3 over 2 from both sides. You'll want to get a common denominator there, which is 4 over 2. So this is going to be 1/2 equals c. Okay, so my final answer is that f of x, the original function, was 3/2 x to the 4th plus 1/2. So there's the original function. All right, the next one I was requested was number 6. This is the average value function. We have to know that formula. So the formula is 1 over, so anytime you see average value of a function, you do 1 over b minus a, which is the closed interval information, a to b. And it is the integral from a to b, so it's a definite integral, of f of x dx. So this would be 1 over 3 minus a negative 2, so that'll be plus plus. And then we go from negative 2 to 3 of 3x to the 4th minus 2x dx. So this is 1/5, negative 2 to 3, of 3x4 minus 2x dx. These are both just polynomial terms, so we can do the antiderivative normally. So we just want to keep that 1/5 out front. So that would be 3x to the 5th over 5 minus 2x squared over 2. So that's just going to be x squared. And we have to evaluate that at -3 and then minus what we get when we evaluate it at -2. So I'm going to work that out up here. So this is 1/5, big bracket, parentheses, 3 to the 5th over 5 minus 3 squared minus 3 times -2 to the 5th over 5 minus -2 squared. So let's work this out. This is really 3 to the 6th on that first top. So 3 to the 6th is 729 over 5 minus 9 minus, I'm going to keep my parentheses for a second, -2 to the 5th is -32. 32 times 3, so that's going to be -96 over 5. This is 4, and it's got a minus sign on it. Because that was a negative at the very beginning of that second group, we have to change both of those signs. So this is really 729 over 5 minus 9 plus 96 over 5 plus 4. So let's see what happens when we add the like terms together. So 96 plus 729, since they both have the denominator of 5, is 825. That's divisible by 5. So if we divide that by 5, that just gives me 165 minus a 5, taking 1/5 of that. So that's 1/5 of 160, and that would equal a total of 32, I believe. Let me double check myself. Yes. So this is our average value. Okay, another one I was requested to do was number 9. It's a profit function, but you're given an initial condition, so that, and a derivative essentially. So you're doing the antiderivative and you're finding the particular solution. So we would be doing that P of x, big P of x, is equal to the integral of negative 20x plus 250 dx. This would be negative 20x squared divided by 2, so that's going to be negative 10x squared plus 250x plus, I usually use k when I'm dealing with the money problems. And then this is my ordered pair, this is my x, this is my p of x. So I get 610 equals negative 10 times 5 squared plus 250 times 5 plus k. We're going to be able to solve for k. So that's 25 times negative 10. So that's negative 250 for that first term on the left side, or right side, I should say, sorry. And then 250 times 5 is 1250, so plus 1250. If we add those together, that's 1,000 on that side. Subtract 1,000 from 610, and that gives me my k. So that's negative 390. Now your final answer is to write the profit function. So you need to write P equals, go back to this line right here where you had the plus K, negative 10x squared plus 250x minus the 390. So there's my formula. Okay, and then I was also requested to do number 12 and 13. These are the midpoint rule ones. So at the time t in seconds, the velocity v in feet per second of a car is given by v of t equals 5 plus 0.05 t squared for t's between 0 and 6. So that's my closed interval, 0 to 6. We're going to use 3 rectangles to estimate how many feet were traveled during this time using the midpoint rule. Okay, so remember to find your what we call delta t or delta x, which is the length. This is the kind of the width, I think of it, of each rectangle. So we're going to have them in a uniform width. So we would do the formula b minus a divided by n. So 6 minus 0 divided by 3 is 6 over 3, which is 2. So each rectangle has a length of 2. So that means you can find your subintervals by starting at 0 and adding 2 to it, because that's the start point. So 0 to 2. Then your next rectangle starts immediately in the same spot, so 2 to 4, and then 4 to 6. You use these subintervals to find your midpoints. So that would be a midpoint 1 of 1, midpoint 2 is 3, and midpoint 3 is 5. Remember, if you don't know what it is by just looking at it, add these together and cut it in half. So like 2 plus 4 is 6, cut in half is 3. 4 plus 6 is 10, and cut in half is 5. Now the formula says if you take, to find your midpoint rule, you take the delta t and you times it by each of the midpoints evaluated in the function. Remember, what that gives us is that gives us the height of each individual rectangle. So you just need to come over here to the side, and these are all v's, I should say, not f's, because our function was v of t. So you would put v of 1 together, then v of 3, and then v of 5. So this is 5 plus 0.5 times 1 squared, and then 5 plus 0.5 times 3 squared, and 5 plus 0.5 times 5 squared. So we want to work each of those out. So 1 squared is 1, so that's just 5.5 when you add those together. That's 9 times 0.5, so 9 times 0.5 is 4.5, plus 5 will be 9.5. And the last one is 25 times 0.5, and then plus 5, so that's going to be 17.5. Now remember, delta t is the 2 that we got here, so this is 2 times 5.5 plus 9.5 plus 17.5. So add those together, and then times it by the 2. So that is 65 feet is the estimate, since this was measured in feet per second. Okay, the last one that I was requested was to do number 13, which has two parts. A part, sorry, it wants to jump. A part is to have the midpoint rule. And then the B part is to do it with a definite integral. So let's do A part first. We want to do 6 rectangles. This one's a little more involved. So remember, my rule for finding my delta x is I do B minus A divided by the number of rectangles. Well, my B is 3, my A is 0, because that's my interval. And then I'm dividing that by 6. So it looks like each of my rectangles is going to be a half long. So we'd go from 0 to a half step, start at a half, go up another half step, start at the 1, go up a half step, start at the 3 halves, go up a half step, start at the 2, go up a half step, which would be 2.5, start at the 5/2 and go up a half step. So if you've done all of them, you should have 6 rectangle intervals. We're going to find the midpoint of each of these, and then we'll plug them into our function. Okay, so if we add that together, that's 1/2. Cut it in half means you're doubling its denominator, so that's going to be 1/4. So that's midpoint 1. Midpoint 2, you would add these together. That's 3 halves, and then you pretty much double the bottom, so that's 3/4. So pretty much you're just getting quarters. If you add these together, that's 2/2 plus 3/2. That's 5 halves, and then you half it, so that means it's going to be 5/4. And you can do this part on your calculator. You don't need to do it in your head, but 3 halves plus 2, that's going to be 7 halves, and then you half it, so that was supposed to be 3 back there. So this is M4, so that's 7/4. And you can turn these into decimals too. I'm fine with that. This would be 4 plus 9, so that's 9 halves, so it's 9/4. And then this last one would be 6 plus 5 if we get a common denominator, so that's 11. So you notice it's just going up by an odd number on each top. So there's my 6 midpoints. So I need to plug each of those into my function. Thank goodness my function's pretty small. So we're doing 4x squared. So 4 times 1/4 squared, 4 times 3/4 squared, 4 times 5/4 squared, 4 times 7/4 squared, 4 times 9/4 squared, and 4 times 11/4 squared. This is 4 times 1/16, which would be 1/4 when you reduce. This is 4 times 9/16, so that's going to be 9/4, so that's my second one. And then we get, that's 25/16, so that's going to be 25/4. This is 49/16 times the 4, so that's going to be 49/4. This would be 81/16, so that's going to reduce to 81/4. And this is 121/16 when you square it. So that is 121/4. So that's all of my values for my function at each midpoint. And then remember, we times all of that by the delta x. So we need to add all those together. So that's 1 plus 9, so that's 10, plus 25, plus 49, plus 81, plus 121. That equals 286. Let's see if that's divisible by 4. It's not equally, but it's fine. So this is 1/2 of 71.5. And if we half that, we're going to get 35.75. So that is the approximation using the midpoint rule. To find the exact answer, we do the indefinite integral. We essentially just do the integration and we evaluate it from 0 to 3, which was our closed interval. So we do the definite integral, I should say. So 0 to 3 of 4x squared dx would be 4x cubed over 3 from 0 to 3. So that is 4 times 3 cubed over 3 minus 4 times 0 cubed over 3. 3 cubed is 27, and then you divide it by the 3 on the bottom. That makes it 9. So that's just 36. This turns into 0. So 35.75 is a pretty close approximation to the 36 using the midpoint rule. Okay, so that's the end of this video. I hope this answered all of your questions, and I will see you guys tomorrow for the test.